let's wait and see.
Yeah. Okay, so thanks to everybody. I'm Moukarram, and thank you for having me here. I'm really pleasure to be here and to talk to you about some lessons I've learned from actual situation at home and at work. The title of my presentation is How My Children Forced Me to Adopt DevOps at Home, and how the same practices could be helpful also at work too. So I will start with a small example about how you do some actual real-life work. So let's say you want to clean your home, and assumably you have more than one room. So let's say if you start with 4 rooms, the basic stuff to do is to go through all rooms and do the exact same practice. So if you want, for example, to vacuum, when you have plugged your vacuum cleaner, the intuitive way to do that is to go through all rooms and clean them all. If you are mopping, it also sometimes, or usually you do that by mopping every single room because you have everything at your hand. And usually that works also very well. So if you have a room of 4, or a home of 4 rooms, living room, bedroom, a kitchen and a foyer, you will end up with having like a plan like this one. So you remove the furniture, so you have place for vacuuming, for mopping. You do these 2 activities, the vacuum and the mopping, and then you return everything back. Of course, it's simplified, so you may have some additional steps, like at the kitchen you may need also to clean the stove, but that's basically speaking how it works. So it will take you maybe 1 or 2 hours, and you will be done with everything. It turns out that works only when you are not interrupted. So now let's get in some children into the game, and that change everything. So now while you are vacuuming, one of your children will start to vacuum because he likes the sound of the vacuum cleaner. So somebody will take that, you're blocked, and that child, and I have one of those who just loves to vacuum, will take the vacuum cleaner, and you are blocked. At that time, maybe a different child wants to eat something, so you have to go to the kitchen, turn the furniture back because that child has to sit somewhere, give them something to food, and basically you have also to repeat some steps. You have to remove the furniture again at the kitchen, you have to do some vacuum cleaning. Maybe that interruption happens later at your work while you're mopping. Some of your children maybe needs to sit somewhere or eat a bag of cookies or whatsoever, and now you have to re-vacuum the living room. Maybe you're just too tired because that took you, instead of 1 or 2 hours, 3 hours, and it's too late, and you are not allowed to vacuum anymore because it's after 10 o'clock. Maybe you end up never returning the furniture back because you're tired and it's too late. This situation happens every time you try to do that, and it's basically very frustrating. You end up having like a permanent construction site at home, similar to maybe a German Autobahn, where you see some construction sites, nobody is doing anything, no progress, but it always feels like a construction site for years. So at some point you realize that will not work. You need somehow to optimize that workflow. If you look back at this workflow, the basic problem with it is it takes too long for the first room to be ready. And in that time, like from the beginning where you started removing furniture to the step where the living room is done, actually you don't have any workable room at home because everything is removed, and you don't have a room to send the children to, like stay there while I'm doing stuff. And you try to optimize this workflow, and you end up dividing the home in multiple steps. Like, I'm happy if I'm done today with the living room, maybe I can focus later on a different room. So you end up doing every single step for one room, finish that room, and then moving on to the next room. If you have a closer look at this approach, you see it's actually just small batches. Like you don't want to deliver the whole home at once. You are happy if you clean one room and you are done then with that and ready to move to the next room immediately, or maybe a day later or whatsoever. Also, having an interruption in this workflow would mean less damages, because at worst you will have to repeat the steps you have done for one room and not for every room. It turns out it's very similar to what you can have at home, having at work. Having children at home is like having, let's say, a chaos monkey unplugging stuff all over the time, and you have to react to that and be always ready to do something. A small introduction to my company, because it's relevant, because I will be also talking to you about how we change the culture, how we managed to get there where we are, and to adapt from our perspective, like to be able to deliver quickly and flexibly. So my company is named Suru. We started as a company, maybe you have heard of, Grohe. You know it for a sanitary product. You probably have seen some of the faucets, it's bathrooms, like everywhere. And we started with the first product with a digital accompanying app for it. The device on the above, it's a guard, which is a water sensor you install in the pipeline. It measures your water withdrawal, it measures your consumption, and it's able also to detect anomalies and shut down your water supply in case it detects, for example, a pipe break or any water leaking. The smaller devices at the bottom we call them sensors. You can position them in some places where you may expect water to leak out. For example, at the washing machine, if they detect water, they will also communicate with the main device to shut off your water supply. So it was the first IoT product at the company, at Grohe, which is like a traditional company for creating hardware. And it was successful. We started with that, and then we shifted, like we adapted to some knowledge of the market, and now we are a separate company called Suru, like a sister company of Grohe, and we have changed in the way we do business a lot. So we started with the company with no programmers at all. Like we were outsourcing all development activities to companies. So like a few companies helped us build these products. And then we started to focus more on building stuff in the company, to having a team internal to the company, to shift from, or to offer additionally to the B2C solution a B2B, so where we are targeting insurer. And we were providing insurer not only with the prevention of water damages, but also with some insights about how water behavior, how they can reduce wastes, and of course how to reduce the payouts for water damages. We did this shift like from one extreme of the spectrum to the other end, and while we are doing that, we had two requirements which we like always have to balance between them. First requirement is how to respond to a changing landscape. So said a lot has changed, how we develop software, our customers, how to do that. And also we needed to provide our customer with a stable environment. And we had always to balance between them. Like if we change nothing, then it's very stable, like nothing will break. But if we had to adapt rapidly, we have to change, then stuff could break, and we needed to have a balance between that, but also we needed to be able to respond more fastly. So during the last years, we have moved from the beginning where we didn't have any schedule for deployment, like every few months something new will come out, to go through deployment every 6 weeks, every 4 weeks, every 2 weeks, like a factor of the number of weeks needed in one sprint. And our next step, which we hopefully be able to do soon, is to have an on-demand deployment, which is assumably like more often than once every 2 weeks. So we go step back and we see at the beginning where we're having some issues to adapt very rapidly. What were the problems at that time? When we looked into that, we found out it was like kind of spiral where we were stuck in the middle of that. We have changes, and every change can break a lot of stuff, which means we have very long testing phases. We have to test not only new features, but also everything else which may have also been broken while something else was developed, which means releases were delayed oftenly, and while the development went on, means the pipeline or the backlog were getting bigger and bigger, which also we need to test more for the next time. So it was like a spiral, and we were caught in the middle. And we needed to break it. So the first step, of course, is to identify where are the bottlenecks, what are our constraints. For us at that point, it was pretty easy, like to see, okay, we are spending too much time in the testing, how we can break that, how can we reduce the number of errors we are finding in every test cycle so we can bring stuff out more quickly. To buy some time, the first step for us was to see the errors, like to not see the error in the production, to see them while they're happening, like as soon as they're better. So we had to install and monitoring to monitor everything, to install telemetry, like to monitor not only errors, but also the usages. Like if we are, for example, if we are talking in terms of accessing database, let's say DynamoDB, which you measure in read units. So if we always have 5 read units every minute, and sometimes we are only having 3, you can say there is some problem. So there is alarm, and let somebody have a look into that. And we are also, of course, live testing for the running system, so kind of monitoring, simulating of devices, sending data, receiving them, just to be able to see problems while they happen. And that helped us a lot. Like, not prevent us from doing errors, but being able to see the errors as fast as possible bought us a lot of time. So at that time, then we could have a deeper look into the problem, why we were having these problems in the first place. After we did that, we figured out we could reduce the factors creating these errors to 3. One factor was the complexity of the code. It was getting out of hands, how complex any change would be. We had deployment errors, and we had too many handoffs between teams, inside the same team, and context switches. So we went down to addressing these points one by one. About code complexity, one issue we had at the beginning, it was very different coding styles. As I said in the beginning, we were depending on multiple companies to deliver our source code. And usually when working with external companies, people are changing very often, which means like people will have less time to get into the team, and they go after a period, so you have new people with maybe new ideas, new coding styles, and sometimes it's even possible to see like who has written this piece of code at which time, just from the style of it. Unit tests were outdated, so we had them, like if anybody could ask, yeah, sure, we have them, but they were not running automatically, which means they were outdated. They did not reflect the status of the code. Somebody wrote these unit tests at one point, they were running, but then stuff were changed and nobody updated the unit test. And generally speaking, the language we were using, JavaScript, didn't encourage refactoring, which means if it's working, like we had it just right now with the notebook, if it's working, don't touch it. If you touch it and break it, it's yours. So it was not doing it well, because as you saw, it's entropy. It's like it will get worse. Code will get worse through time. You need to do something against that to make it better. That's why we started an initiative to improve the quality, like quality of the software, quality of everything we had in the system. First step was to use a more developer easier language. So not here into getting in the war of dynamic typing and static typing, but we changed to TypeScript. Everything new was written in TypeScript, so that's the advantage of TypeScript and JavaScript. You can use both of them in one project, and whenever we had to adapt something, we have modified it to TypeScript. TypeScript had the advantage of having better developer experience, like just the typing, the additional information you have as a developer, just worth it. It has a richer domain model. Domain modeling is a fancy word of saying invalid states are impossible, more or less, but it means like you are guided through the valid cases, and you seldom will end up in an invalid state. You are having a possibility to detect errors faster while you go, like because just the compiler, the transpiler will tell you about the errors. And also you have easier or better refactoring experience because the tools have more information to start with. So whenever you want to refactor the code, the tools will be much better. It will give you actually advices that you can follow. That was one step, and then we wanted to also improve the quality, like also for new changes, how we get there. So we said, okay, let's use all tools that's possible. Like everything that can help us is like using the low-hanging fruits. If there's a tool which can help us, let's use it. That's why we built a quality gateway. This quality gateway, like whenever somebody creates a pull request, which means even before your code gets into the main branch, a lot has happened to make sure your code is valid and a good quality. So we will run all unit tests, and we'll also run integration tests, and we also will make sure that you have tests with minimum coverage. Like we define a number which we then increase during time. We also run static code analysis. So we are detecting with SonarQube or SonarCloud, we're detecting code smells, errors, and also we could enforce unified coding styles. It didn't matter at that point who was coding, because the tool were forcing some kind of styles which we cared of. And of course, like because we were using a cloud environment, it was possible to deploy every pull request. Like every time something happened, you want to add code, just deploy it, run it on a live system, or more or less similar to the live system, and see if everything is okay. That helped well with the code quality. Then we figured out we have problems when the deployment. And why we have them, I'll come to that point now. The issues were described in this way. We could have errors in every stage. So we were having 4 stages: a development stage, a staging one we called, and pre-prod and prod. And errors could happen in every stage, like even new errors which weren't available or weren't there in the previous ones. The issue with that was we have, and I mean, of course, it's like a DevOps and the DevOps, but in this case, we are very clear separation. There were even 2 different companies. So we have a company which is writing the code, and we have the company which is responsible for operating it, for live monitoring it, for deploying it, for the resources for that. And every company had like an ownership of 2 states, and between those, we had a handoff. And this handoff contains a lot of stuff, like of course the code needs to be deployed, but also a description of the infrastructure that you need, which kind of components will be there. I need an access to that database, I need a different table in that database, I need a queue to write some messages into, and also usage patterns, like I will be using this database more, so please increase the alarm thresholds. And that was done at this point. And which means like, okay, so somebody will define that, will write that as a code for the pre-prod, and then you will run it on pre-prod, and then you need to figure out, did that work? Was the description enough to have the system which we're already running on staging now running on pre-prod? Or like was something missing in this description? So we said that will not work. We need to have a different way of doing that. That's why we, although there's still 2 different companies, that's why now everybody is involved at the development of any feature. So it's basically one team. Whenever we define a feature, no matter how small that, even it's a minor change, like everybody will be in the team. And we made sure that the environments are identical. They were not in the beginning. We made sure that all environments are identical. Otherwise, no need to have them in the beginning. So if every environment is different, why you have multiple of them? And we also made the ownership of the code common to everybody. So it's not like the code is owned by dev team and something else, the code for the infrastructure owned by somebody else. Everybody in that team was responsible for the code that the team produced, which made it much easier to actually produce production-ready code from the beginning. At the level of pull requests, the code was done to be deployed everywhere and has everything in it which needed: the alarms, the monitoring, the infrastructure, and of course the code itself. Like one minor thing which we also modified is what we used to have like 3 branches in GitHub, because said, okay, we have like 3 environments which were matters: staging, pre-prod, and prod. So we have 3 branches, and whenever you put something in one branch, it will be deployed to that one, plus infrastructure which was deployed like manually, not out of the branch, but yeah, that's how it was before. And we said we need to bring that closer to one source, because we were having, for example, problem in pre-prod which was not there on staging, just because sometimes you have to cherry pick from one branch to the other, which means you will introduce new bugs on the way, because it will be just fast forward. Okay, so we adapted this strategy. Like there are a lot of videos online about trunk-based development. So a very good one from the Build conference, Microsoft. Don't remember the name of the guy who did it, but yeah, there are a lot of videos about that. And for the releases, now we were just taking this main branch which we had, which also had the continuous delivery to one of the environment. We now say, okay, every 2 weeks, we will take a branch of it, we will deploy it to pre-prod and prod. If we have to do bug fixing, we will do that on main. And we need also maybe to cherry pick it for the production. But after this 2 weeks, that branch is dead. Nobody is using it. We will make a different branch for the next deployment, which means our deployed branches are always very close, if not identical, to master. These both changes enabled us to reduce the risk to fail. If something will fail, it will fail in the beginning. It will not fail when you deploy it. It will not fail when the customer sees them. It will fail at the beginning. And that was like a major change. We still have maybe errors, but they are not visible to anybody else except for the team, because we will be able to find them as they happen. Then we had like the last point, which is about too many handoffs. So the first handoff which I talked about was between the infrastructure handoff between the developers and the operation team. That we have now already taken care of. We have one team. There is no handoffs, there's only cooperation, and when a pull request is created, everybody has signed it off, the developer and the operation team, so it's already there. But also we had different kind of technical handoff between technical teams. I will come that in the next slide. And also we were having a lot of context switches because we are having deployment cycles, which means at one point you're done, but the next step is blocked because you have to wait for the next deployment to be able to react to that. So how we fix the handoff between the technical teams? At the beginning, we have the team structure like this one, where we had the three major components. Let's say we have the device, which is like the physical device you have at home, showed in the beginning. We have two teams or one team now for the backend with cloud backend on AWS, and we have an app team. And every feature could have like touch 1, 2, or even 3 of these teams. Of course, there were different teams for big data, for some other parts of the system, but simplified, we have 3 teams. And for one feature to be done means every team had to do something with that, and which means also there are a lot of handoffs between these teams. So if the device creates something like sending new kind of data to the backend, then there must be somebody on the backend to handle this data, and if you want to show it in the app, you need to adapt the app for that. So there were a lot of handoffs in between, and that's why we changed the team structure. We have created what we call cross-functional teams, which means one team, one feature-focused team that may change, like not every sprint, not every 2 weeks, but that may change. But at least when they are working in one team, they are focusing on one feature. And you have everybody you need for that feature there, from the device, from the cloud, or from the app. That doesn't fix everything because we still have different deployment cycles. So for the back end, you can deploy every 2 weeks or like every 1 day if you want to. And then for the app, if you want to deploy it or to have a new version every week, that could be possible. But for a device, which is a physical one running somewhere, that's not possible because you need to make sure it's not breaks the device. So you have to take a lot of more care measurements before you can deploy something new. But still, like having this kind of cross-functional team helped a lot. So one last step, and like it's like you have always thing to do. So it's not like we will do this one step and then we are done. We can all go home. But still, like why we say having a frequent deployment is meaningful and why it makes sense. Let's say we have a feature which will take two days. Currently, if you do work on that, you have it in 2 days. Then you have to wait for it to be deployed to pre-prod, where actually user with actual devices. Okay, field testers we call them, but actual user can test that on pre-prod. And then whenever that's done, may be satisfied, maybe you need to do something, but then you have to wait until the next prod deployment, which will happen 1 week later, which means from the time where you started to the time where you can get actually feedback from actual users, not only from the field test users, could take a few weeks. Now, when we will switch, and hopefully soon, to a more frequent deployment, that will change radically. Like, we can focus on that. So whenever you have reached the end of the development, you can already release that feature to be tested by field testers. And whenever that's done, you can already be deployed to production to get actual feedback from customers, which will now, not only you will have less context switches in between, but also you will be able to get feedback much faster. And also you are not then, like, you will not have a deployment cycle. So if a feature starts 2 days later, it will maybe finish also 2 days later, but it's not like then you have to wait for the next cycle for that. Hopefully this step will be done soon. So the takeaways, like if you forget everything I said, well, how can be summarized? All these steps are about eliminating waste. First thing to take with you is quality does matter. It's not like just for your ego. It's not like code polishing. Quality actually does matter. If you provide quality code, it will help you to deliver faster. Always focus on small batches, like no matter what you're doing, cleaning houses, delivering software, helping customers, always deliver something in small batches. And also try to eliminate manual work in the deployment process, because it will take out the fear of changing, of modifying. It will take out the fear of improving your software in small batches. And reduce handoffs as much as possible. And with that, I come to the end of my presentation. Thanks a lot. If you have a question, thank you. Question, happy to answer them now or later.
Thank you so much. Well done. So we do have 2 questions on the screen. So let's see how well my reading skills are. Ooh, 3.
Oh, more.
So let's start 4. So let's start with the question: how did you convince your leadership to spend time on this? I can imagine that fighting fires is obviously much more important.
Because at one point, if they trust you, they will ask you, of course, why we have these fires in the first place. Okay, so I'll go here. Okay, and basically that's what you have to, like, if you see the fires, you can explain why did that happen, how we could prevent them, and of course it's again small batches. If you do a small batch, even in the improvement process, and you can show results very fast, that's a good motivation to invest more in the improvement process.
Awesome. And so one more question for the hallway track, so we'll not answer it here. But how do you make your children not spread dirt from the not clean rooms into the clean rooms? I'll leave that one up to the hallway track. Go find him during lunch after the talks. And thank you so much again.
Thank you.
Give him a round of applause.
Thank you.